Hey guys, so we are going to do our second installment for our stoichiometry tutorials, right? In this second installment, we'll focus on the added element of figuring out what your limiting reactant is based on the amount of reactants you start with and the balanced equation and so on. So remember, that's that little insert step in between taking our initial question and calculating the amounts of product we get. Remember, that's what stoichiometry does for us. It allows us to predict how much product we get based on the amount of reactants we start with, okay? But sometimes we have two different amounts of two different reactants. We gotta figure out, well, which one of these is the limiting reactant, okay? So, like I said, this is gonna be ChemQuest 31, skill practice number 2, right? Which puts us on page 5. So that's that bottom question on page 5 of ChemQuest number 31, you guys. All right. And so here is the question itself with 412.5 grams of calcium carbonate, right? So we're given two different amounts and 521.9 grams of aluminum fluoride. So those are our two reactants, right? We want to figure out which of those is going to be limiting how much product we get, right? Because often in a question like this, you don't have like an exact stoichiometric ratio where they're both going to be completely consumed. Typically in a question like this, one of them will be completely consumed and one of them will have some leftovers, right? That's kind of how this functions. Okay, so step 1, like with all stoichiometry problems, we've got to make sure we have a balanced molecular equation. So let's go ahead and write that one down, right? So we're going to add calcium carbonate. So +2 -2, so we got CaCO3 plus aluminum fluoride, which is +3 -1, so this is AlF3, right? This is the part you guys should know how to do by now. And that is going to yield, right? So essentially again, my aluminum and calcium will switch places. So calcium and fluorine, so this is going to be CaF2 plus Al2CO3, 3, right? And then again, these formulas are based on the charges of the individual elements, right? We have to make sure it comes out neutral. I'm not going to review that with you guys again. You should know how to do this part, right? Now, what we have to do next then is make sure we balance things here, right? So I see that I have 2 aluminums there. Let's try 2 here. All right. Now, I have 3 carbonates here, so I'm going to try a 3 here, right? So that gives me 6 fluorines here. I only have 2 there. 3 calcium, I'm gonna put a 3 there. And that should do it. Okay? So we have our balanced equation, right? So that part's done. Now, so what we need to look for then is this sort of ratio, 3 to 2 with our reactant. So again, with the limiting reactant element that we're adding here is we're focusing on this side of our equation, the amount of stuff we're starting with, which of our reactants is going to determine how much we end up with on this side. Okay, because typically in a question like this, one of them is excess, one of them is limiting. Now it's possible to have an exact ratio, in which case they both are completely consumed. But in the case of this question, one of them is going to be excess, one's going to be limited. All right. So how do we go about figuring out which of our reactants is the limiting reactant? All right. And that's the $1 million question for this particular setup right here, all right? So we should notice in the question that the amounts of my reactants are in grams, right? And we need to do some sort of comparison in amounts of our reactants, okay? Can't do that when they're in grams because every different element, atom, compound, etc. has a different mass based on the number of atoms we have. So we have to kind of get rid of that molar mass idea. And get them in a unit that we can compare, that is moles, right? That's what we've been spending so much time on. So my first step is I got to take my 412.5 grams of calcium carbonate, convert that to moles. So I need to take my 521.9 grams of aluminum fluoride and convert that to moles. So I'm going to do that right here. All right. So I have 412.5 grams calcium carbonate, right? And I need to convert that to moles, so I'm just going to divide that by the molar mass of calcium carbonate, which would be 1 calcium plus 1 carbon plus 3 oxygens, right? And when I do that, I should get 100.09 grams of calcium carbonate and 1 mole of calcium carbonate. All right, so it's going to be a simple division problem here. 412.5 divided by 100.9 will tell me how many moles I have. When I do that, I should get 4.12 moles of calcium carbonate. Okay? Now, I'm going to do the same thing over here with my aluminum fluoride, right? So, according to the question, I am starting with 521.9 grams of aluminum fluoride and 3 fluorines plus 1 aluminum gives me a mass of 83.98. One mole. And that should give me 6.21 moles of aluminum fluoride. Okay? So, what we need to recognize with these two numbers that I'm just writing down right here, right, is that this is the actual amounts that I have. So I'm going to annotate this with I have 4.12 moles of calcium carbonate, and I have 6.21 moles of aluminum fluoride that I'm starting with. Okay? So the trick now is to figure out which of these two is excess and which of them is limiting. All right? Now, we should sometimes just be able to eyeball my ratio. And here's what I'm going to do, right? So according to this, I should have 3 moles of calcium carbonate versus 2 moles of aluminum fluoride. That would be an exact ratio. Okay? Now this is the trick. So essentially I know that my moles of calcium carbonate needs to be more than my moles of aluminum fluoride, and it needs to be about 1.5 times more, right? Because 3 over 2 is 1.5, right? So what I'm going to do is I'm going to look at my amount of calcium carbonate. I have 4.12 moles, 6.21 moles. Now, do I have more calcium carbonate than aluminum fluoride? The answer is no, right? So that tells me automatically that I have excess aluminum fluoride, okay, which would make my grams of calcium, my moles of calcium carbonate my limiting reactant. Okay, so again, according to this ratio, I should have more moles of calcium carbonate than aluminum fluoride, if this was to be exact, right? In fact, I have more aluminum fluoride, so that means I have extra aluminum fluoride. I've got excess, right? Which would make this limiting. Now, if we can't simply eyeball like that to tell, what we can do then is we're going to take one of our two reactants, and it does not matter which one, okay? It doesn't matter which reactant we choose. We're just going to take it in moles and multiply by the mole ratio. What that will do is that'll tell us how much of the other one there needs to be to use up all of whatever reactant we have, okay? So let's do it this way. Let's take 4.12 moles of calcium carbonate. All right, and I want to figure out, well, how many moles of aluminum fluoride do I need to use all of this up? All right, and that's what multiplying by the mole ratio does, by the way. It tells me how much of another substance I need to use it all up. All right, so if I have 4.12 moles of calcium carbonate, my ratio is going to be moles of calcium carbonate to moles of aluminum fluoride, right? And my ratio is 3 calcium carbonates to aluminum fluorides. So when I do that, I should get 2.75 moles of aluminum that is telling me, like I just said, the amount of aluminum fluoride required to use up all of this. So you can kind of picture this. These are what I actually have. This is what I need. All right, so this is aluminum fluoride. So I need to compare this number to the amount of aluminum fluoride that I have. All right, so what I need to do here is just exercise some logic, right? Do I have more than I need or less than what I need of aluminum fluoride? So this number, 6.21, is significantly larger than 2.75. So I have more than I need, right? When you have more of what you need, that makes that element the excess, right? And once you know which one is excess, you know which one is limiting. Okay, so now I can finish out this problem. I can predict how much product I get, all right? Now this is why we have to know which one's limiting, because it's the limiting reactant that determines how much of this stuff we get on this side, okay? So if I want to be able to predict how much calcium fluoride I get and how much aluminum carbonate I get, I have to know which of my reactants is going to limit that, right? So what I can do at this point is, because I know that I have excess aluminum fluoride, right? It is not going to determine how much product I get. This one is. So I can actually erase this. I know my limiting reactant. So I'm going to erase this to save some space. And this right here. Right? So this is the number I use to solve for my amount of product. Okay? I'm going to do, I have two products, so now I got to do two stoichiometry problems. One for calcium fluoride, the second one will be for aluminum carbonate. All right? Now, nice thing is I'm already in moles of my reactant, my limiting reactant, so I could just go right from there. I don't have to start back over with grams of calcium carbonate. I'm already in moles. All right? So, problem number one, I'm going to have 4.12 moles of calcium carbonate. All right. Now, doesn't matter which one I do first. We'll just do calcium fluoride. So that's written first, right? So my mole ratio here is 3 to 3. So that makes this easy. So it's 3 moles of calcium carbonate become 3 moles of calcium fluoride. All right. So that's an easy step. 3 to 3 there, right? Now, how many grams of each product do I produce? So this is going to put me in moles of calcium fluoride. I need to convert that to grams, right? And we know how to do that. In 1 mole calcium fluoride, right, there is a mass of 78.08 grams, right? So again, to go from moles of calcium fluoride to moles of to grams of calcium fluoride, excuse me, right? I just multiply by the mole mass, 1 calcium plus 2 fluorine. All right, and when I do that problem, I get about 321 grams of calcium fluoride. All right, so now I know how much calcium fluoride I get in grams, right? My next step would then be to calculate the mass of aluminum carbonate. All right, so again, I'm going to set it up exactly the same way. It's going to be 4.12 moles of calcium carbonate. Okay, so it's going to, this time I'm going to go moles calcium carbonate to moles of aluminum carbonate. Okay, and this time my ratio is 3 moles of calcium carbonate to 1 mole of aluminum carbonate, right? So I am going to have to divide in that step. All right, and again, because I need to know not just the moles of calcium or aluminum carbonate, I want to know the grams of aluminum carbonate. Right? I just need to know my molar mass, so 2 aluminums plus 3 carbons plus 9 oxygens, and that gives me a big mass of 233.9 grams of aluminum carbonate. to do that, oddly enough, I get 321 grams of aluminum carbonate. So, what do we just do, right? So let's walk back through the logic of each of our steps. So, originally we took our 412.5 grams of calcium carbonate, right? Which we was added to 521.9 grams of aluminum fluoride, right? Those amounts are in grams, right? And when we have two different materials, we can't just compare masses, right? We have to have our magic moles to compare amounts, right? So the first thing we did was we took these two things, we converted them to moles, right? Then we had to decipher from the mole quantity which one of those is limiting, right? So once we know how many moles we have, we then compare the amounts of moles using the mole ratio, right? If we match that mole ratio exactly, essentially they're both limiting. If one of them is more than it needs to be, or more than that quantity, that one becomes excess, right? Which would make the one that is not excess the limiting reactant, right? We then don't worry about the excess reactant. We just take the amount of our limiting reactant and use that to solve for the mass of our products, right? And so what we have to consider in all this is because aluminum fluoride is our excess, that means after the reaction, there's still going to be some aluminum fluoride left over, a certain amount. And you could calculate that too if you wanted to. All right. Anyways, I hope you guys find this a little bit helpful. And keep with this. It's a slow process, lots of steps, lots of thinking along each step of the way. But with practice, you'll get it. You'll get it.